Hello friends, this video on integrals part 30 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched part 1 to part 29. Let's start a new topic called integration by parts. Before we study this, let's analyze why do we need this. There are certain scenarios where we have to integrate. For example, I'll show you xy, or there are two functions f1, fx1 or gx. They are product of two functions. My equation is of the product of two function form. I know how to integrate this, how I know to integrate this. In that case, I can use this formula. For example, I have fx gx. I want to integrate this over dx. This is nothing but fx constant, fx into integration of gx minus f dash x gx dx, the whole thing again integration of dx. That is, I'll tell you what, it is nothing but fx integration of gx minus, you write the same thing twice. I'll tell you how to do this. One shortcut I'll tell you. Then you do f dash x and then again you integrate this, and that is what I'm looking for. See, fx integration of gx minus f dash x into integration of gx, the whole thing again integrate with respect to dx. This is nothing but fx gx dx. Once again, shortcut, remember, this is nothing but fx integration gx minus fx integration gx. The only thing I am doing here is I am making it f dash x, and then the whole thing I am again integrating. That is what I am doing. That's all. That is what the formula says. Fx integration gx minus, you see, f dash x into integration of gx and then whole thing integration. If you notice this, actually for some function, for example in this case we are integrating gx twice, right, gx, but we are never integrating fx. So the proper choice of first and second function is critical here. I'll tell you why. Because see, the whole funda of applying these tools is to make a complex integrand to simple integrand, right? That is my motto. Whether I'm using substitution or fraction by part or this integration by part, the main funda is to make complex integrand to simple integrand. So here in this case, the choice of first and second function is critical. For example, in this function, let's suppose this is my first function, this is my second function, and I want to find integration of x cos x dx. This will be nothing but x, if this is my first, this is my second, integration of second, that is cos x dx, minus, you say derivation of first into integration of second, right? And the whole thing again integration, correct? And this is nothing but x cos x becomes sin x integration minus derivative of x is 1 into, and integration of cos x is again sin x, so 1 into sin x, whole thing is again integrated. This is nothing but x sin x plus cos x plus some constant, correct? Now let's see the same thing. I'll pick this time cos x x dx. Here I'll say this is 1, this is 2. The same thing I wrote in this fashion. Here my cos x is first function and x is second function. So this becomes cos x integration x dx minus d by dx of cos x, right, integration x dx, the whole thing again integrate, correct? So this becomes cos x, x becomes x square by 2 minus d by dx of cos x becomes minus sin x, correct? And integration of x becomes x square by 2. The whole thing I am saying integrate. Minus minus, I will take it plus here. So if you see now, my equation is like this: x square cos x by 2 plus integration of sin x x square by 2. This was a little simpler actually. I am making my equation more complex, correct? Now, thus if you see, in first case when I choose one x as first function and cos x as second function, I was able to reduce this to a simpler function, and then I was able to derive the integral also. In second case, when I'm choosing cos x as the first function and x as second function, instead of simplifying it, I'm making it all the more complex. Thus, the choice is more important. Which should be the first and which should be the second is very much important. So to make your life simple, we have developed a list of preference order. So if it is inverse trigonometric function, that will be taken first, logarithmic function second, algebraic function third, trigonometric function fourth, exponential last. So this is the order. So if I have, like, suppose fx into gx form, I'll take fx to be first if fx is in this order. So if I have something, let's suppose tan inverse x into, let's suppose, p to the power x, so this guy I'll take as first function because this guy is my first in order. If I have, let's suppose, log x and then tan inverse x, here also I'll take tan inverse x first because tan inverse x is first. If I have log x into, let's suppose, x to the power 8, in this case you will take log x first because log x is in the first order. If I have, let's suppose, x to the power 8 into sin x, in this case I'll take x to the power 8 as the first function. Correct? If I have some exponential function, is considered the last option. So that is the order. First, if I have trigonometric, inverse trigonometric, I'll take that. Then if I have some log, I'll take that. If log is also not there, I'll take algebraic. If not algebraic, I'll take trigonometric. And exponential is the last. There's a memory tip for that. I am late. When you say I am late, I is inverse. M you can ignore also. I am, you can ignore the M part because M is nowhere. Or you can say I late. And L is for logarithmic, A for algebraic, T for trigonometric, E for exponential. So we'll solve some question. We'll use this memory tip also so that you understand this whole logic. Let's try to prove that formula which we have shown you. The formula was, I'll write the formula once again, integration of fx dx, sorry, fx gx dx is equal to fx integration of gx dx minus integration of f dash x gx dx, the whole thing you again integrate. This was the form, correct? And let's prove this. To prove this, I'll use that chain rule of derivation. Actually, we know that d by dx of, if I have two function uv, that is nothing but u dv by dx plus v du by dx. This is something we know, correct? Let's integrate both sides. If you integrate both sides, integration of this, integration of this, integration of this, that is uv. Integration of derivative is the function itself is equal to integration of u dv by dx plus integration of v dv by dx, correct? So let's find this guy, u dv by dx. U dv by dx is nothing but uv minus integration of v du by dx, correct? It is u. Now let's do one thing. If you compare these two, if I take u as fx, right? Sorry, this is integration actually here, right? This is integration. If I compare these two, if I take u as fx, u is equal to fx, and dv by dx is equal to gx, my formula is all same. If you see, this guy will become integration of u is nothing but fx and dv by dx is gx, correct, is equal to u is what, fx. If dv by dx is gx, my v is nothing but integration of gx dx. So v will be integration of gx dx, integration of gx dx minus integration of v du by dx. V is what? Integration of this guy g dx into du by dx is what? F dash x, f dash x, and the whole thing is integrated once again. Correct? And that is what my formula says. You see, this is nothing but fx integration of gx dx minus integration of, you take this side or this side, doesn't matter. You say xy integration or yx integration is one and the same thing. So you can write in this fashion, f dash integration of gx dx, and the whole thing is now integrated. Correct? And thus I have proved this formula. Very simple, just by using the multiplication derivation I have proved this formula. So before we start solving questions, let's observe some points in this integration by part. First thing is, the proper choice of first function and second function is very much critical, and I am late is a critical memorative for this, for first function. And while finding the integral of second function, we don't add any constant, as you have seen. Normally when you say integration of, let's suppose, sin x dx, we say it is nothing but cos x plus c. But in this case we don't add any constant when integrating the gx dx part, because it doesn't make sense. You keep adding constant, or better is at the last we add a constant. And second thing is, it is not applicable for all cases. There are certain scenarios where you will not be able to use this integration by part, and that is true for any case. If you are using substitution method, or you are using fraction part, or you are using fraction functions, or you have some partial, I think, formulas, right? You have formulas, or using trigonometric formulas. In all these you will find you will not be able to use all these for all the questions. So some questions you have to use this, some question you have to use this, some question you have to use multiple of this, and these things will come by factors. There is a special type of integration by part, that is, if functions of this form, e to the power x fx plus f dash x, this is in braces dx, that is equal to e to the power x fx plus c. I just prove this so that we'll have questions on this and we can directly use the formula. So the theorem goes like this: e to the power x fx, I can write this guy as, actually this guy is nothing but e to the power x fx dx plus e to the power x f dash x dx, right? This is nothing but e to the power x, I'll take common. This is nothing but e to the power x, I'll take common, right? And integration of fx dx minus e to the power x, differentiation of e to the power x will be e to the power x itself, right? Fx dx, and the whole thing integrated. Why? Because this is nothing but differentiation of e to the power x, and that is e to the power x itself. Or to avoid confusion, let me write like this, right? Plus this part, e to the power x fx dx. Correct? So if you see, this guy is nothing but, thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.